Here's the thing that nobody tells you about lightning. The part that actually kills you is not the electricity. It is not even the heat. It is something far stranger, and understanding it reveals one of the most violent physical environments that can exist on the surface of this planet. You have been told lightning is dangerous, but you have never been told what it actually is from the inside. And once you understand what is happening in that channel of superheated gas, you will never look at a thunderstorm the same way again. Let us set the scene. A bolt of lightning lasts on average about 200 milliseconds from first flicker to final fade. But the actual return stroke, the blazing visible channel you see light up the sky, exists for roughly 30 milliseconds. Within that window, physics does something almost impossible. It creates a tube of plasma approximately 2 centimeters wide, no wider than your thumb, and superheats it to around 30,000 degrees Celsius. For context, that is 5 times hotter than the surface of the sun. Not the core, the surface. That glowing roaring star 150 million kilometers away is cooler than what is happening between a cloud and the ground right above your backyard. So here's the hypothetical. You are somehow suspended inside that plasma channel for exactly 1 millisecond. Not touching it from the outside, not near it, inside it. What would actually happen to you? And why does physics say the answer is stranger than instant vaporization? First, let us understand what you are actually inside. A lightning bolt is not a wire of electricity moving from cloud to ground. It is a stepped leader, an invisible channel of ionized air that propagates downward, met by a streamer coming up from the ground, and when they connect, the return stroke blasts upward at roughly 1/3 the speed of light. In that moment, the air inside the channel does not just heat up, it transitions into the fourth state of matter. Plasma. Every atom in that cylinder of air loses its electrons. The gas becomes a soup of free electrons and bare atomic nuclei, conducting electricity at almost no resistance, releasing a blinding white light across every spectrum from radio waves to ultraviolet. The current passing through that channel peaks at around 30,000 amperes. The pressure wave it creates is so violent that it compresses the surrounding air faster than the speed of sound, and that compression is the thunderclap. The channel itself expands outward at supersonic speeds in the microseconds following the return stroke. Now, you, inside, 1 millisecond. Here's where the science becomes genuinely strange. At 30,000 degrees Celsius, matter does not simply combust or even vaporize in the conventional sense. The thermal energy arrives so fast that the mechanism of destruction changes entirely. Before your body could thermally conduct that energy inward, the outer layers would undergo rapid ablation. The plasma surrounding you would immediately begin ionizing the outermost molecules of your skin. You would not burn. You would convert. Carbon, hydrogen, oxygen, nitrogen, the molecules of you would begin transitioning into their constituent plasma state before any meaningful heat transfer could propagate deeper. And this is where 1 millisecond matters enormously. Heat transfer through biological tissue is extraordinarily slow compared to plasma dynamics. In 1 millisecond, thermal diffusion through water and protein moves on the scale of micrometers. The interior of your body, your core temperature, your organs would register almost no temperature change whatsoever in that window. The violence would be happening at a scale thinner than a sheet of paper at your outermost surface. But the electromagnetic fields are another story entirely. 30,000 amperes induces a magnetic field around the channel that would induce massive eddy currents through any conducting medium, and your blood and tissue are absolutely conducting mediums. Those eddy currents would begin disrupting cellular electrical potentials across your entire nervous system simultaneously. Every neuron firing at once, every muscle contracting at once. If you are finding this as fascinating as we do, hit that subscribe button right now and ring the notification bell so you never miss a video where we push science to its absolute limits. Now back to that millisecond. The pressure wave. This is often overlooked entirely. The shock front expanding from the lightning channel moves outward at speeds exceeding 5 kilometers per second in the first microseconds. Being inside the channel means you are at ground zero of a pressure event that creates momentary local pressures hundreds of times greater than normal atmospheric pressure. 1 millisecond is enough time for that shock wave to interact with every gas-filled cavity in your body, your lungs, your sinuses, your inner ear. The barotrauma alone from that pressure pulse would be catastrophic across your entire respiratory system. So what is the honest answer? In 1 millisecond, you would experience simultaneous surface plasma ablation of your outermost tissue, complete electromagnetic disruption of every nerve in your body, catastrophic barotrauma to all air-filled cavities, and intense ultraviolet and X-ray radiation exposure to every cell. Your core would survive that millisecond largely thermally intact, which is perhaps the most disturbing part of all. The thing that would end you is not simply being cooked. It is being assaulted by four completely different mechanisms of physical destruction at the exact same moment, each operating faster than the biological systems designed to respond to them. Lightning is not a single danger. It is a simultaneous weapons array of heat, electromagnetism, pressure, and radiation compressed into a cylinder the width of your thumb, and it fires across the sky dozens of times every single second across the face of this planet. The next time you stand under a darkening sky and hear the first rumble building in the distance, remember this. That sound you hear was made by air doing something that only the surface of the sun normally achieves. And between you and that plasma channel, the only thing standing is the random geometry of where the stepped leader decided to reach. If this video changed the way you see something as ordinary as a thunderstorm, share it with someone who thinks they know everything about lightning. Subscribe for more deep dives into the physics of the extreme. The universe is far more violent and far more fascinating than anyone told you. We will see you in the next one.